we are going to look at exercise 8.2, sum number 1, first subdivision. So before we get into all this, we have to know the values of sine 30, cos 45, all of that, which is given in the textbook in the form of a table. So we should be really thorough with the values of these trigonometric values so that we are able to substitute them easily. So now let us look at the first subdivision. With respect to the first subdivision, I'm going to substitute the values here. So let me make use of the right side space on the screen. So first subdivision. So we know very well that sine 60 degree is root 3 by 2. Okay. And cos 30 degree is also root 3 by 2. Plus sine 30 degree is 1 by 2 and cos 60 degree is also 1 by 2. So now root 3 into root 3 in the numerator becomes 3 and 2 will become 4 in the denominator. And also 1 into 1 is 1 and 2 times 2 is 4. So we get 3 by 4 plus 1 by 4, which is 4 by 4. Therefore, you get 1. So that is about the first subdivision. With respect to the second subdivision, 2 into tan 45 value is 1. But since they have given square, I'm introducing the square. Plus cos 30 value is root 3 by 2. Since they have given square, I'm squaring it. But for the whole term, we should be very careful here. And minus sine 60 value is root 3 by 2. Again, they are asking us to square it. If you look at the question, they are square terms. So you write the value and then put a whole square. Now, something that is important here is you can directly cancel this root 3 by 2 the whole square minus root 3 by 2 the whole square. You need not square them and then cancel them because anyways they are the same terms but with the positive and negative sign. So root 3 by 2 the whole square and minus root 3 by 2 the whole square will get cancelled. Need not expand them and then subtract them. So finally you will get 2 into 1 square is 1. So you get the answer as 2. So when it comes to third subdivision, again, we are going to do it in the right side of the screen. So just a minute. Yeah. So third subdivision, the question goes like this. Please look at the third subdivision. Cos 45 degree. So the value of cos 45 degree is 1 by root 2 divided by the value of sec 30 degree will be 2 by root 3 and the value of cosec 30 degree will be 2. So first let us substitute the values. The substitution should be proper. I repeat, cos 45 degree, we all know it is 1 by root 2. Sec 30 is nothing but the inverse of cos 30. Cos 30 is root 3 by 2. So sec 30 will be 2 by root 3. Similarly, cosec 30 will be the inverse of sin 30. Isn't it? So sin 30 is 1 by 2. So the inverse will be 2. Now having substituted these values, we have to learn how to operate them. The numerator, let us not disturb it. Let it be 1 by root 2. The denominator is a compound term, which means there are two terms. So we are going to take the LCM. So here it will be 2 plus 2 root 3 divided by root 3. So this will be the LCM for this step. So what I'm doing here is nothing but, if you look at the red color writing, so here it means 2 by 1. So now whatever is remaining here, whatever is missing, that should be multiplied. This root 3 should be multiplied here. That is how we take LCM here. So divided by 1 into root 3 in the numerator also. Now numerator becomes 2 plus 2 root 3. 2 into root 3 is 2 root 3 whole divided by root 3. That is the whole point of taking LCM. Okay. Now what we have is, so now we have 1 by root 2 and this can be taken to the numerator and reversed. It becomes ulta. So you get into root 3 divided by 2 plus 2 root 3 within bracket. All of this should have proper brackets like this. So when you take this whole fraction to the numerator, what happens is that it gets reversed, which means root 3 goes to the numerator and 2 plus 2 root 3 comes to the denominator. Now what we have left is root 3 divided by, now you can actually multiply this root 2 with both the terms. Okay. Now when you multiply root 2 with both the terms, the first term becomes 2 root 2 and the second term becomes 2 root 6. Now 2 into root 2 is 2 root 2. If you look at this step, so 2 into root 2 will be 2 root 2 and 2 into root 3 into root 2 will be root 6, 2 root 6, because root 2 and root 3 will get multiplied and become 2 root 6. So after this step, there are few more steps which is called the conjugate step. I'll explain it in short while. We will try to rewrite the step at the last, and then we are going to do something called as conjugate. So the step is root 3 by 2 root 2 plus 2 root 6. So the step was root 3 by 2 root 2 plus 2 root 6. Now, how am I going to approach this? Okay, now this denominator has irrational parts. So we cannot conclude this is the answer. We have to rationalize them. So how do we do it? So I'm rewriting it here. Root 3 by 2 root 2 plus 2 root 6. This is the last step. And from here, we have to take conjugate. So what I mean by conjugate is whatever you have here, the same thing, but with an opposite middle term like this. Okay. The same thing you have to continue in the numerator also. This step is called as the conjugate step. So this is used to rationalize the denominator because denominator contains root terms. So we have to eliminate the root terms. So that is the idea. So now whatever you have here, the same but with the opposite sign. You can see here the plus has been changed into minus. And whatever you write it here, the same thing you repeat in the numerator also. So you multiply like this. For example, if this is a plus b, then you do a minus b, numerator also the same a minus b, you have to multiply. So this step is called as the conjugate step. Now, how do I proceed with this? Now, what happens is root 3 into 2 root 2 and root 3 into 2 root 6. You have to multiply root 3 with each term. Now, what happens is root 3 into 2 root 2 will become 2 root 6 minus root 3 into 2 root 6 will become 2 root 18. So basically, root can get multiplied only with root terms, irrational and irrational, divided by. So the numerator, root 3 into 2 root 2, I have done 2 root 6. And root 3 into 2 root 6, I have done 2 root 18. Basically, root 3 and root 6 are getting multiplied. But we need not take so much of effort as we did in the numerator for the denominator, because denominator is in the form a plus b into a minus b. Intentionally, we did it like that. So a plus b into a minus b. As you can see, they are the same terms, but with just the sign is different, like 2 root 2 plus 2 root 6, 2 root 2 minus 2 root 6, a plus b into a minus b. So we all know a plus b into a minus b is a square minus b square. So this will be a square minus b square, like this. Okay, I repeat, this is a plus b and this is a minus b. So this will become a square minus b square, where a is 2 root 2 fully and b is 2 root 6 completely. Okay, so we do a square minus b square. And in the numerator, we can take 2 as common out. Okay, we can take the 2 as common out. Root 6 cannot be simplified further, but root 18 can be simplified further, because if you just simplify root 6, you will be getting just 2 and 3. There is nothing common to take it as common out. But whereas in 18, we can write it as 2 9s are 18 and 3 times. So for these 3, we can take 1 3 as common and we can write this as 3 root 2. That is the procedure. Basically, we are factorizing 18 and we are getting 2, 3 and 3. So for these 3 together, we are taking 1 3 outside and the remaining thing that you're left with is 2. So this is 3 root 2. So root 18 can be written as 3 root 2 divided by. Now, when we square 2 root 2 and 2 root 6, let me do it in the left side. So when I'm going to square 2 root 2 the whole square, first 2 gets squared, you get 4, and square of root 2 is 2. So you get 8. Likewise, if I'm going to square 2 root 6, then I'm going to square 2 first, you get 4, and then I'm going to square root 6, I'm getting 6, you get 24. So these are the values which I'm going to substitute. So I get 8 minus 24 in the denominator. So finally, you will be getting 2 into root 6 minus 3 root 2 divided by minus 16, because 8 minus 24 is minus 16. The bigger number is 24. So you get the sign of that. And then 2 and 16 will get cancelled 8 times. So we'll continue this. Let us resume. I have written the last step again, which is root 6 minus 3 root 2 by minus 8. This is what we were sitting with lastly. Now, what happens after this is, So basically, denominator has been derationalized. I mean, it has been rationalized. The irrational part has been removed. The root part has been removed. So you get -8. Now, what happens here is, if you are able to take this minus sign upwards, then the terms will get interchanged. What do I mean by that? We can understand that in different way. So because usually denominator need not be like a single term, it need not be negative. So I'm going to multiply this by -1 and -1 finally. Okay. So now what happens is denominator becomes positive. It is just that we are going to conclude it in a proper way. So denominator just becomes 8 and numerator becomes 3 root 2 minus root 6. How? So firstly, why am I doing this multiplication by -1? In order to make the denominator positive. So -8 into -1 is +8. And numerator -3 root 2 into -1 will become +3 root 2, as you can see. And root 6 into -1 will become -root 6, as you can see. So basically, this need not be done like you have to multiply -1 and all of that. If you have a negative sign in the denominator, it is understood that the terms in the numerator will interchange if the minus sign is removed. So that's how we understand this idea. The final answer is 3 root 2 minus root 6 divided by 8. Now we are going to do this problem by substitute. This is the fourth subdivision, okay, in the first problem. So we are going to substitute the values initially. So as we all know, the value of sine 30 is 1/2 and the value of tan 45 is 1. They have given a minus and the value of cosec 60 is 2/√3. So we put a bracket just not to get confused with the denominator. So then we have another denominator, which is sec 30. So sec 30 is 2/√3 and then cos 60. Cos 60 is 1/2 and then cot 45. Cot 45 is also 1. So we should be very careful and very much thorough with all these values in order to substitute them. Now, some of you may think that we have already got some identical terms and you may feel like cancelling them off, but you can't do like this. This cancelling cannot be done because all the terms in the numerator are in fractions and they are associated with positive and negative terms also. So we cannot directly cancel them. So what do? We take LCM in the numerator and LCM in the denominator separately. What do I mean by that? If you take LCM in the numerator, then this will become root 3 plus 2 root 3 minus 4 whole divided by 2 root 3. I'll explain how we got this. So basically, if you look at the numerator, so I'm substituting -1 here just to show you that that is the denominator. So if you look at the LCM for this step, please concentrate only on the numerator. Let us come back to the denominator later. So if you only concentrate on the upper part, then how do we take the LCM? If we don't know how to take the LCM, then you just multiply all the denominators and that will be the LCM. Because if you don't have roots, then it is easier to take LCM. But here we have a root term. So what we do, you multiply all the denominators here. So 2 into 1 into root 3 is 2 root 3. So we understand that 2 root 3 is the LCM. And here we have 2, but there is no root 3. So whatever is missing. So basically the LCM is 2 root 3. Now here we have 2, but we don't have root 3. So we multiply it by root 3 in the denominator and in the numerator. That's how we got this term. Okay. Similarly, here we have only 1. We don't have 2. We don't have root 3 also. So you multiply this by 2 root 3 and we do it in the numerator also. That's how we got this term. And here we have root 3, but we don't have 2. So we multiply 2 and 2. So in the numerator already there is a 2, that becomes 4. That's how we got this term. So basically here LCM means we find that the common LCM is 2 root 3. Okay, and in the first denominator root 3 is missing. In the second denominator, so over here root 3 is missing, and over here both 2 and root 3 are missing, and over here only root 2 is missing. So that is how we do it. So let me erase off the LCM, and the common LCM is 2 root 3, that we know. Okay, so this is how we do it. Similarly, in the denominator also we are taking the LCM. So when we take LCM in the denominator, it becomes 4 plus root 3 plus 2 root 3 whole divided by 2 root 3. This is the LCM in the denominator. Again, the same strategy, I would like to revisit that. So the denominator here is root 3 into 2 into 1. So the LCM will be 2 root 3 again. So here we have already root 3, but no 2. So we multiplied by 2 and 2. We get 4, and that's how we got this 4. And likewise, here we have 2, but no root 3. So we multiplied by root 3 and root 3, and that's how we got this term. And similarly, here we have only 1. Both the terms are lacking here. So we will be doing into 2 root 3 into 2 root 3. That is the LCM. So you get in 2 root 3 in the, that's how we got this term. And whole denominator is this. Now we can directly cancel these two terms, but we cannot cancel these two terms. Please be careful here. We cannot cancel this 2 root 3 and this 2 root 3 because this term is associated with 2 more terms using a plus or a minus. Whereas this 2 root 3 and this 2 root 3 can be cancelled. How can I do that? So as you all know from the previous problem, what will this become? In the numerator, you cannot operate all of them. However, 2 root 3 and root 3 will get added and become 3 root 3 because this is like 1 root 3. So 1 root 3 plus 2 root 3 will become 3 root 3. That's how irrational numbers are operated. So we get 3 root 3 minus 4 divided by 2 root 3. Okay, and in the denominator we get 3 root 3 plus 4 divided by 2 root 3. In the denominator we get this. As you can see, please look at this step. Root 3 plus 2 root 3 becomes 3 root 3 minus 4. Okay, again in the denominator root 3 plus 2 root 3 becomes 3 root 3. Okay, plus 4. I have just written it in particular order. Now in the next step, what happens is 3 root 3 minus 4 whole divided by 2 root 3 is here. And this term, when it goes to the numerator, it gets interchanged. It becomes the reciprocal. I've already told you this. So now what happens is 2 root 3 comes to the numerator and 3 root 3 plus 4 comes to the denominator. Okay, like this. Now you can very clearly see why these two are getting cancelled. 2 root 3 and 2 root 3, how they are getting cancelled. So we can very clearly see that happening. So we basically need not show this step. This step is just for you to make you understand how 2 root 3 and 2 root 3 are getting cancelled. So we can actually skip this step. Skip this step and we can directly cancel 2 root 3 and 2 root 3 here itself. I hope it's clear. Or even in the previous step, we can even cancel it in the previous step itself. I just wrote the step to make you understand how they are getting cancelled. So now what happens is in the numerator we have 3 root 3 minus 4. Okay, and in the denominator we have 3 root 3 plus 4. Now again, we can of course stop at the step provided there was no root in the denominator, but we have a root and we have to rationalize the denominator. So the same conjugate that we did in the previous problem. So same thing, we are repeating it here also. So this is 3 root 3 plus 4. We do into 3 root 3 minus 4 and the same thing in the numerator also, 3 root 3 minus 4. We do like this. 3 root 3 minus 4. This step is called as conjugate, which we did in the previous problem also. So basically, if you have a plus, you do a minus and you repeat the same thing in the numerator also. Now what do you do? Yes, again the same thing that we did previously. So basically, we can multiply these terms. So the numerator looks like a minus b into a minus b. So we can do a minus b the whole square. And because they both are the same terms, right? Or you can even multiply 1 by 1. We can even do that. Maybe we can try that now. And also denominator, of course, since we have taken the conjugate, this looks like a plus b into a minus b, which is a square minus b square. So how am I doing this? So since the numerators look the same, you can see here 3 root 3 minus 4, 3 root 3 minus 4. So we can write them as 3 root 3 minus 4 the whole square. We can do that. And then we can do a minus b whole square. Or we can even just like that multiply and write them. So when 3 root 3 and 3 root 3 is multiplied, listen, let me do it separately and show it to you. So 3 root 3 and 3 root 3, when you multiply them, 3 and 3 will become 9. Root 3 and root 3 will become 3. Again, when you multiply them, they become 27. So all of this I'll be directly doing it. For you to just understand how it's becoming 27, I just showed this step. So now what is happening here is, when you multiply the first two terms, you get 27. When you multiply the first and the second term, you get 12 root 3. And again, you get 112 root 3. And you get 16 in the numerator. So how did I get this? Let me explain. So 3 root 3 into 3 root 3 is 27, based on the steps which I recently told you. And 3 root 3 into minus 4 will be minus 12 root 3. The 3 and the 4 only will get multiplied. So minus 12 root 3. And likewise, once you have done these two terms, again these two terms, minus 4 into 3 root 3 is minus 12 root 3. And minus 4 into minus 4 is plus 16. So this is something that you need to understand. Or in other words, since both are the same, you can even do like this: 3 root 3 minus 4 the whole square. They are repetitive terms, right? So you can write it as 3 root 3 minus 4 the whole square, and you can apply a minus b the whole square formula. Again, you will be getting the same answer. But here I have done like one term by one term multiplication. Denominator appears as if it's a plus b into a minus b, which can be written as a square minus b square. Here a is 3 root 3 fully and b is 4. So a square minus b square. This is what we are doing. Now what happens finally? 27 and 16 can be added. But 27 and 12 cannot be subtracted because it has a root 3. These are very important rational irrational operations. So when I add 27 and 16, it becomes 43. Okay. And then minus 12 root 3 minus 12 root 3, they get added, because minus and minus you add them and it becomes minus 24 root 3. Okay, divided by what you have here is 3 root 3 the whole square. When you square this, you will be getting 27, and when you square this, you will be getting 16. So basically 3 square is 9, root 3 square is 3. So you get 27, and when you square 4 square, you get 16. So the final answer will be 43 minus 24 root 3. See, minus 12 root 3 minus 12 root 3 is minus 24 root 3. Okay, just the rational part will get added, divided by 11. Since the denominator is devoid of an irrational part, this will be the final answer, which is 43 minus 24 root 3 by 11. With respect to the fifth subdivision, this is the question. So we just substitute the values. So 5 cos square 60. So we know that cos 60 is 1 by 2. So cos square 60 will be 1 by 2 the whole square. And please watch out, the square is only for the value of 1 by 2 and not for 5. Plus 4 sec square 30. Now sec square 30 is nothing but 2 by root 3. Okay. The whole square. Minus tan square 45. Tan square 45 is, tan 45 is 1, again square. So this is something that we should know. Okay. So the square will be only for the values and not for the coefficients. What I mean by coefficients is this 5 and 4. They remain the same. That is very, very important. And in the denominator, sine 30 is 1 by 2, again whole square. And cos 30 is root 3 by 2, again whole square. Okay, so this is how we substitute the values. Now what happens? So in the numerator, there is a 5. Okay, we have a 5. And then when you square 1 by 2, you get 1 by 4. Because square of 1 is 1, square of 2 is 4. Plus 4 into, so square of 2 is 4. In the numerator, 2 square is 4. In the denominator, root 3 square is 3. We have to individually square them, and minus 1 square is 1. And in the denominator, square of 1 is 1, square of 2 is 4, and square of root 3 is 3, and square of 2 is 4. So this is